All right, so let's do a quick little recap, a little check-in of what we did on Friday. List all sets the number belongs to. So -5. What type of number is -5? Oh, I know the name. Sorry. Many. Integer. That's right. And a real number. All right, but there's one more in between. Oh, not natural because it's negative. Faisal?
Rational.
Rational. That's right. All right. If you refer back to the first page of your blue book, okay, if you go back to the first page of the blue book, this circle right here, you can see integers are part of rational numbers, which are part of real number. Right? And you can see Cheryl, natural number, and integers are outside of the natural number circle. So that's why it doesn't belong to that. Yara?
So when you list all the things, does it have to be like
No, it doesn't have to be in order. Okay, what about -2.54444444 repeatedly? What type of number is this? Oh, this is just in general. It's a recap. Parson? Real and rational. Perfect. All right, it's rational because of the repeating decimal. All right, can somebody give me an example of an irrational? James. Pi. That is the obvious one. Okay, so these are the type of questions you'll see in the multiple choice. If we were to have the chapter 1 test, these will be the type of multiple choice questions you'll see. Okay, so that's what. So for those of you who weren't here on Friday, that's what you missed. Make sure you remember this circle. This really helps you distinguish between the different types of number and what belongs to what. Okay? So for example, natural numbers are part of whole numbers, but whole numbers are not all part of natural numbers because it's outside of that circle. Okay, and then again, so for those who weren't here Friday, this was the homework, page 3. So try this out tonight, and then the answers are right beside it. Right, so that will get you guys caught up. Okay, moving on to today's lesson, page 5. Page 5, we're going to talk about subsets and sets and subsets. Okay, page 5. So let's open up to that page. If you can't see it clearly, you have the exact same thing in front of you. Okay, Nathan, are you on page 5? Okay, let's open up our books to page 5. Okay, so sets and subsets. This set right here, blue, green, red, yellow. So the number of elements, it just means how many things is in the set. So I have 4 different colors. So I have 4 elements. Okay. What about this? How many elements do I have in here? Yara? 1. That's right. Yeah, 0 is still a number. Right, so I have 1 element in this set. What about this empty set then? James? 0. Okay. So an empty set is still a set. Okay. Now we get into what a subset is. So subset are smaller set within the bigger set. We call this the parent set, and this is called the subset. So you can think of it as like the parent and the kids. You can't have the kids without the parents. Okay, so 7, 9, and 12, all three numbers are from this parent set. So this is called a subset of this. Whereas number 3 right here, why is this not a subset of this parent set? Cheryl?
Because it doesn't have the numbers aren't in the parent set.
Which one in particular is not there?
0.
0, right. So all the numbers you have to be able to find all the numbers from the parent set to be considered a subset. And because this one doesn't have 0, so it's not. Okay. Let's try, oops. Let's try this one then. 5F. All right, so I'm choosing questions to go over with you guys. 5F, the set of all integers that are multiples of 5. So if I were to write out a set using these squiggly brackets, okay, multiples of 5. So long.
5, 15.
Yep, 5, 5, 10, 15. Okay, all that. But are these all it is? What's the minimum? What's the minimum integer that is a multiple of 5? Negative something. That's right. So you actually have infinite number of choices here. You could have negative 10, negative 5, 0, 5, 10, 15. Okay, so that's how you write a set. Okay. Now this is a tricky one. Okay, number 6. List all the subsets of the set 1 and 2. So think of this as the parent set. All right. Yep. No, so you want to list all the subsets. So let's say this family has the mom and the dad. All right. So a subset of it could be just the mom, just the dad. What else? Yeah.
1.1.
And no, remember, a subset is numbers that you find from here. Okay, so we're not talking about between 1 and 2. It's just these elements, based on these elements. Jeffrey?
Both.
Yeah, both. So you can have the mom and the dad. Yeah. And there's actually one more.
None of them.
None of them. The empty set. Right. So you can have nobody. Nobody, the mom, the dad, or the mom and the dad. Right. So all these are subsets of the parent set because you can find all of this from here. Okay. Let's try number 8 together. Number 8 will give you the true or false questions. Okay, and number 8 ties into what we talked about on Friday. Okay, true or false? I want you guys to participate. All right. The set of whole numbers is a subset of real numbers. So who says true? Whole numbers are a subset of real numbers. Right? Believe in yourself. Don't look around. If you think it's true, put up your hand. Who says false? Okay, so for those who participated, good job. You are correct. True. Whole numbers are within the real number system. Okay. B. Natural numbers are subset of integers. True? False? Alright. Natural numbers. Are natural part of integers? Yes, it is. Alright, and if you look back at this circle, All right, natural numbers are part of integers. Right? So yes, so that means natural is a subset of integers. All right, C, whole numbers is a subset of natural numbers. True, false. Good. All right, because whole numbers are not natural. Whole numbers are 0, 1, 2, 3, 4, 5, 6. Natural is just 1, 2, 3, 4, 5, 6. So that's why it's not. Rational numbers are subset of real numbers. True, false. It's true. Right? Rational numbers are part of real numbers. Okay? Remember, real numbers is everything. Um, E, rational numbers is a subset of rational. Sorry, let me reread that. Irrational numbers are a subset of rational numbers. True, false. Good. Okay, all of you guys are pretty confident with that. Yep, it's false. They are opposite of each other, so they're definitely not subsets of each other. All right. Prime numbers. What are prime numbers again? Zachary?
Like numbers that don't have more than two factors.
Right, only one in itself. So, example 2, 3, 5, 7,
13.
11, 13. Right, okay, so those are prime numbers. Are they a subset of rationals? True? False? Good job. You guys are getting the hang of this. True. All right, last one. 2, 3, and pi are a subset of rational numbers. True? False? Why false? Right, okay. But next time, let's put up our head. Good. Pi, because of the number pi right here. Pi is irrational. Remember, all three would have to be part of ration to be a subset. Okay. Um, number 11 right here, they use Z instead of I for integers. Technically, Z is the official symbol. Okay. But so on the test or on the quiz or in the homework, if you use I or Z, they're both good. They're fine. Okay. Moving on. Page 10. I'm skipping all the way to page 10. Right, page 10. Okay, let's say who's been quiet? Nathan, you've been quiet. Can I get you involved? Can you give me any three numbers between 0 and 1? Any three numbers between 0 and 1? Pass? Nathan? No? Okay. Hugo, can you help him out? Any three numbers between 0 and 1? Yeah, 0.3, 0.4, and yeah, 0.5. Okay. What about four rational numbers between 3 and 4? Kaya? Sorry, Kafia? Sorry.
3.2.
Oh, sorry.
3.3.
Yeah.
3.4. 3.5.
Yeah, perfect. All right, they are rational numbers because it's a terminating decimal. Your decimal ends, so I know it's a rational. All right, nice and easy. Now, what about question 6 right here? How many natural numbers are there between 1 through 10? How many natural numbers? Nikon? 10. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10. 10 elements. B, 6B. How many whole numbers are between 0 and 10? James? 11. Yeah, 11 elements in this set. How many rational numbers are between 1 to 10? I heard it. Benjamin? Infinite. That's right. Just like how we wrote up here, any decimal is a rational. So you have infinite number of elements. Then what about irrational? How many irrational numbers? Faisal? Also infinite. So whenever you have decimals, you know you have infinite number of possibilities. Okay. What about E? How many real numbers are between 1 through 10? Also infinite. Right. So I wanted to go over this because it talks about number of elements. That next, number 7, is density. Right? So density is something new to the curriculum. And I write EQAO here because lately I've seen a question on EQAO about density. Right? Yeah, so every once in a while I'll give you guys these little hints. All right. Density. So, for example, how dense would you say this class is? Not very dense. Compared to what other class do you have this semester? Geography. Is geography really packed? Kind of. Yeah. Okay. So you know how you were comparing one classroom to another classroom, right? And so in terms of the spacing, yeah, we have quite a few empty desks here. So uh, in comparison with this math class and a geography class, you can say that we're not as dense. But what if I were to say this class and your gym class? Okay. Yeah. Okay. But do you ever feel crowded in gym class though? Sometimes. Okay. So the boy says no. Why not? Space is bigger. That's right. So when we compare, like for example, number sets, if the parent set is the same size, then we can just compare geography class with a math class. But when the size is not the same, then we have to use this formula to compare the density. So number of elements divided by range. So this is your very first grade 9 formula. Okay, write that formula down. Okay. So for the first one right here, oops. All right, yeah. The set of whole numbers between 0 and 30 and the set of rational numbers between 0 and 30. So which set is more dense? So whole numbers between 0 and 30, how many numbers are here? Whole numbers between 0 and 30. James? 0 and 30. 31, right. Okay, so there's 31 numbers here. And this rational numbers between 0 and 30, how many elements is here? James? Infinite. So which one has more? So this one. If you follow this formula, you can think of it as 30 divided by the range is 30 minus 0. So 30 over 31, using my calculator, Where is my calculator? Oh, right here. Okay, so 30 divided by 31. Oh, sorry, 31 divided by 30, you get 1.03. Okay, infinite divided by 30. What's infinite divided by 30? Infinite. Right, so this one is more dense. Okay, now for A, did I have to do the denominator? Technically, did I have to do the denominator here? No, because this was between 0 and 30. This is also between 0 and 30. Just like when we were talking about classroom to classroom, I don't need to worry about the denominator. I just see which one has more people in it. Okay, so this one is more. What about B, the set of real numbers between -10 and 10? How many elements is here? Infinite. Good. And the set of integers between -10 and 10. How many integers are between here? 20, yeah. Okay, so which one is more dense? This one. Sorry? 0, so 21. Right? 9, 8, 7, 6, 5, 4, 3, 2, 1. Yeah, and 0. So yes, you're right. 21 elements. Good job, James. Okay. Prime numbers between 1 and 100 and natural numbers between 1 and 100. Natural, yeah.
Good job, Jim.
Good job. I like the encouragement. Okay, the set of even numbers between -50 and -20, or the set of irrational numbers between -50 and 20. Jeffrey? Sorry, not Zachary?
Eating.
So
Negative.
so these are only the
Sorry, irrational numbers.
irrational because okay, irrational because you can have infinite number of numbers in between -50 and -20. Okay, but what about this one right here? I added in this one extra example. Integers between 0 to 5 or natural numbers between 0 to 10. Alright, so this one, notice the size of it is different. So now we're comparing a classroom with a gym. So we have to consider the range now. We actually have to use this formula. So how many integers are between 0 and 5? 6. Yes, it's 6. Did someone say 6, 7? Okay, and the range. So the range between 0 and 5, so 5 minus 0, 6 over 5, which is 1.2. Sorry, question? Okay. And then natural numbers between 0 to 10. How many natural numbers are here? So 9. That's right. 9 over 1, 2, 3. Yeah, it is 10. Who said 9? I trusted you. Yeah, so it is 10. But good. That means you guys are paying attention. Okay. And then the range. 10 minus 0. So 10 divided by 10, you get 1. Higher the number, the more dense it is. So it is this one. Okay. Here's one more. F. One more. Real numbers between 0 to 10 or real numbers between 0 to 20. Okay, who says the first set is more dense? The 0 to 10s is more dense. Who says 0 to 20 is more dense? Who has a different idea? A third answer. I like the thinking. I like the discussion. So who has a third option? Who has a third answer? Yeah? That's all? Excellent. That's both are equally dense. Why? Because infinite divided by anything is still infinite for both real numbers. Alright. So but I know that some of you are probably thinking, but wait, miss, the size is bigger. But because the size is bigger, that also means the number of elements is also bigger. And so when you do infinite divided by 10 or infinite divided by 20 is still infinite. So both sets are equally dense. Okay, one last thing, last part of the lesson, density property. So one last term I wanted to touch on. Density property means you can always find a subset from a parent set. Right? So for example, okay, natural numbers between -10 to -5. Can you find a subset of natural numbers between -10 to -5? No, because natural number starts from 0, right? It starts from 1. So nope, I cannot find a subset from that. So it does not have the density property. What about real numbers between -10 to -5? Yes, because I can always have infinite number of subsets from, between that. And so yes, this has the density property. Okay, so that is today's lesson. 27 minutes, a little over than our usual time because I did the quick little recap questions at the beginning. Any question on today's lesson? Okay, so you do have a lot of time, like a good 40 minutes to try today's homework, which is all the way up to page 11. Okay, if you think that's a lot, it's actually not a lot because there are some that says answers on the side. So up to page 11. Up to and including 11. Yeah, 5 to 11 basically. Okay, but that's also in the between. There are answers. Yes, there are a couple of pages of answers in between. And I'm giving you guys 40 minutes to get started on the homework. Okay.